Hello everyone, welcome to Sai Tutorials Jamkandi, where 10th class Kannada medium maths, science, English as well as 10th class English medium maths, science are available in our YouTube channel, also in regular classes. So please subscribe our channel and join. Dear students, in earlier classes we have discussed electric charges and fields and related concepts. So in today's class we have discussed charge and its properties, fundamental properties of charges, auxiliary properties of charges, methods of charging body, Coulomb's law. So, and the Coulomb's law in vector form, and some important points to remember about the concept. So, in today's class, let us discuss electric field. Okay, in today's class, let us discuss electric field. See, this electric field is historically, previously was discovered by a scientist called Faraday. This electric field is introduced by a great scientist, that is Faraday. Which is also called as electric line of force. Electric field is also called as electric line of force, which is the geometrical representation of the electric field, and those are imaginary lines or curves. See, electric field is introduced by Faraday, who was one of the physics physical science scientist, and this is also called as electric line of force. This is also called as electric it is also called as electric line of force. Okay, see, the path along which unit positive charge move in electric field is called as electric line of force. See, also called as, see, the electric field at a point. Okay, the electric field at a point is defined as a force experienced per unit positive test charge, that is Q naught, placed at that point is called as electric field. By seeing the mathematical expression, you can derive the definition. Okay, the electric field at a point. The electric field at a point is defined as a force. It is defined as the force experienced per unit positive charge, that is Q naught. The force experienced per unit charge Q naught placed at that point, that is electric field. Or also you can define the term electric field, that is electric field is measured in a newtons per coulomb. Okay, what is the SI unit of force here? Newton. And what is the SI unit of Q naught? Charge, that is coulomb. So the SI unit of electric field becomes Newton per coulomb. It's easy, right? It's easy. See, electric field is measured in Newton per coulomb. Its direction is always from positive charge and towards a negative charge. See, the important phenomenon that we need to note here is the direction. The direction is always from positive to negative charge. This is the important phenomenon we need to remember. And electric field E at a distance r from a point charge q, okay, at a distance r from a point charge q is denoted by E is equal to 1 by 4 pi epsilon naught into q, that is from a point charge q divided by that distance r square. This is the mathematical expression for the electric field at a distance r from a point charge q. See, electric field is a vector quantity. What do you mean by vector quantity? Because it is having the magnitude as well as direction. Here I have mentioned its direction is always from a positive charge and towards a negative charge. Therefore, E is a vector quantity which is having magnitude as well as direction. Thus, electric field is a vector. And the resultant electric field at a point, the resultant electric field at a point due to several charges is equal to the vector sum of the fields due to the individual charges. I have said the charge has a property called additive nature. Okay. In the same way, electric field at a point due to several charges. Okay. There are several charges in a system. The electric field at a point due to several charges is equal to the vector sum of the fields due to the individual charges. See, by taking an example, let us consider an electric field which is in the vector form whose sum is equal to E1 but in the vector form plus E2. We need to make the sum of those electric field in this manner. So this is all about electric field. Okay. Electric field at a point is defined as the, see, electric field was introduced by one of the scientists, that is Faraday, and this is also called as electric line of force. This is also called as electric line of force. And electric field, what do you mean by electric field then? See, electric field at a point is defined as the force experienced per unit positive test charge q naught placed at that point, that is electric field. The SI unit of electric field is Newton per coulomb. So its direction is always from positive charge and towards a negative charge. Towards a negative charge. So electric field at a distance r from a point charge is denoted by E is equal to 1 by 4 pi epsilon naught into q divided by r square. So E is a vector quantity because it is having the magnitude as well as its direction. So the resultant electric field at a point due to several charges is equal to the vector sum of the fields due to the individual charges. This is all nothing but electric field. The next concept that comes to you is principle of superposition of electric forces. Principle of superposition. When coming to the superposition principle, we can derive the different force that acts on that electric field. Okay, that acts on the electric force acts on that particular field. See, let us consider the diagram here. Okay, let us consider the diagram here. See, if the system, it is a kind of system that contains n charges. See, that is n charges is nothing but, for example, q1, q2, minus q3, q4, minus q5, etc. Okay, let the system contain n charges, n number of charges, that is q1, q2, minus q3, q4 and minus q5. The force acting on a q charge, or q2 charge due to q1, the force acting on a q1 charge due to q2, q3 up to so on qn, then the charges are like this. See, let us consider the resultant electric force. We need to derive the resultant electric force. Suppose, let us consider the 5 point charges. The resultant electric force at a point is the vector sum of the forces due to various charges. we have considered five type of charges, that is the force, resultant force is equal to F12 because the force on second charge, the force on second charge due to the first charge, that is F21, and similarly the force on one charge by two second charge, that is F12, F13, F14 up to so on. This is nothing but the force acting on a charge 1 by 2, the force acting on charge 1 by 3, the force acting on charge 1 by 4, up to so on. This is known as the principle of superposition of electric force. Here, the central, here the main charge that is acting is Q1, they have considered here. Similarly, the system force on Q due to Q2 charge, force on charge 1, force on charge Q1 due to Q3, force on charge Q1 due by Q4. This is all nothing but the resultant force. This is all nothing but resultant force that acting on that kind of system. This is known as the principle of superposition. This is known as the principle of superposition. You can also give the statement, that is, according to the principle of superposition, the resultant force, okay, this is the resultant force on any charge due to number of other charges is the vector sum of all the forces acting on that charge due to other charges. Acting on the charge due to other charges, the individual forces are unaffected due to the presence of other charge. This is the statement of the principle of superposition. You can note down. According to the principle of superposition, the resultant force on any charge due to number of other charges is vector sum of all the forces acting on that charge due to other charges. See, the individual forces are unaffected due to the presence of other charges. This is the statement of principle of superposition. Okay, dear students, I hope so you have got the concept, that is principle of superposition of electric forces. Then how will you derive this one? Force, for example, let us consider the one force is equal to, what is the formula to write the force acting on the two charges? That is F12 is equal to 1 by 4 pi epsilon naught into the force acting on the charge Q1 by Q2 at a distance R12 square. This is first equation. Similarly, F13, which is in the vector form, vector sum of the all the forces. For example, let us consider F13. How will you write this? 1 divided by 4 pi epsilon naught into Q1 is the charge acting on the body, that is the force acting on the charge Q1 by Q3. What is the sign of Q3 here? Minus Q3. Therefore, divided by R13 square. This is the equation number 2. So suppose if you go on writing like this by considering the n number of system of charges presented here, you can add the vector sum of the forces due to various charges you will get. So have you got the superposition of electric forces? So this is all about the principle of superposition of electric forces. I hope this concept is clear to you. The next, the first and foremost important concept, that is electric dipole. This is a very important concept to your CET as well as NEET concepts, that is electric dipole. Let me change the pen. This is very important concept. See, what is electric dipole? They have given you here that two equal and opposite charges separated by a small distance are said to form an electric dipole. So what do you mean by two equal and opposite charges then? Okay, let us consider an example by making the simplification. Suppose two equal and this is two equal and opposite charges. Let us consider this one as Q1. This is Q1 charge and this is Q2 charge are separated by a distance. Are separated by a distance. Let us consider this is the origin point and that is represented as O, and the distance of the charge from the origin, let us consider it as A, and also from origin to another charge the distance is A. Okay, so the total distance from charge Q1 to charge Q2 is 2A. So the total distance between the two charges are that is 2A. Now, the two equal and opposite charges are separated by a small distance are said to form an electric dipole. And next thing is every dipole. Okay, every dipole is associated with a dipole moment. This is denoted by, dipole moment is denoted by the letter P bar, whose magnitude is equal to the product of the magnitude of one charge Q and the distance 2A between them. This is the expression for dipole moment. Okay, every dipole is associated with a dipole moment, that is P bar, whose magnitude is equal to the product of the magnitude of any one charge Q and the distance 2A between them. See, the direction of P bar is from negative charge to the positive charge. Suppose, see, they have mentioned here that the direction is of the dipole moment is always from negative to, okay, is always from negative to positive. So let us consider this Q1 as minus Q1 and this is plus Q2. So the direction of dipole moment is always from negative charge to positive charge. It is a coulomb. Its unit is coulomb meter. See what is by considering the dipole moment P bar, what is the SI unit of Q? I mean charge, that is coulomb, and distance is A, that will be in the meter. So the SI unit of dipole moment, that is coulomb meter. Have you got this? And the dimensional formula for the electric dipole, can you just guess the SI unit of, dimensional formula for electric dipole? Yes, dear students, the dimensional formula for electric dipole, that is M L T and A. So there is nothing above those dimensional formulas, so it will be like 1. Then what is electric dipole moment then? What is electric dipole moment then? I have said that it is a product of magnitude of either the charges, and distance between the two charges is called as electric dipole moment. And what is electric dipole in the sense? It is a product of a system of two equal and opposite charges separated by a certain distance is called as electric dipole. Have you got the difference here? In simple way, two equal and opposite charges separated by a small distance are said to form an electric dipole, but the product of the magnitude of any one charge q and the distance 2a is between them, it is called as electric dipole moment. See, the direction of dipole moment is always from negative charge to the positive charge, and its unit is coulomb meter. And there are some applications related to electric dipole. So let's go further. I hope this concept is clear to you. There are some application type of kind of questions related to the electric dipole. First and foremost thing that we need to learn is field at field at a point on the axial line of electric dipole. See, the field at a point on the axial line of the electric dipole. So consider an electric dipole. Consider an electric dipole, for example, axial line. So let us consider the straight line here. Axial line. So it is a axial line. Consider an electric dipole consisting of two charges. Same way. That is minus q and plus q. These are the 2 point charges. One is minus q and another one is a plus q, separated by a distance 2a. Separated by a distance 2a. And let P be the point on the axial line. Okay, let us consider a point P somewhere else on the axial line. So the axial line may be infinite. Is it or not? So let us consider a point P bar. Okay, let us consider a point P bar on the axial line at a distance r from the center of the dipole. See, from the center of the dipole, let us consider this is the center, right? This is the center. So let P be a point on the axial line at a distance r from the center of the dipole. From this origin to that point, the distance is r. Am I right? Now, the electric field at a point P due to a charge Q. Okay, electric field at a point P. At a point P due to minus Q. That is, for example, E bar is equal to P bar at a point P bar divided by 4 pi epsilon naught into 2R. I mean, from charge minus Q. It is directly they have mentioned you here. But the thing is, E1 is equal to 1 by 4 pi epsilon naught into charge Q, that is minus Q divided by R plus A. Am I right or not? R plus A whole square. Why did I have written? Why did I written x plus A? Why did I write x plus A whole square here? Because the distance from the origin to that point is R, and the remaining distance from origin to minus Q, that is A. So the total distance from minus Q to point P is R plus A whole square. This is R plus A whole square. This is equation number 1. Am I right? And uh, if we consider electric field E2, okay, electric field at a point P due to plus Q, whose value will be 1 by 4 pi epsilon naught of plus Q divided by R minus, what will happen here? R minus A whole square. Why it will be R minus A whole square? Because the total distance minus the origin, from origin to plus Q, that is the distance is A. Therefore, we need to subtract it from the total distance at a point P. So R minus A whole square it will be. So equation number 2. Then the net electric field at a point P due to a dipole becomes E2 minus E1. Okay, E2 minus E1. The net electric dipole becomes E2 minus E1. This is E net. So it will become E2 bar minus E1 bar. So by substituting all the values, we will get that is E bar is equal to P bar divided by 4 pi epsilon naught into 2R divided by R square minus A square whole square. R square minus A square whole square. So we can make it in an easy way. It is very easy. So by considering this all the substitution, just put it in this equation. Just put it in this equation and you will get the electric field at a point on the axial line of the electric dipole. See, for a point, next thing is for a point on the axis far away from the center of the dipole, meaning a short dipole. I mean, the short dipole, E bar will becomes 1 divided by 4 pi epsilon naught 2 P bar divided by R cube, because we have neglected A here. Only consider R because of the if. For a point on the axial line, for a point axial line axis, for a point on the axis far away from the center of the dipole, it will becomes E bar is equal to 1 by 4 pi epsilon naught 2 P bar divided by R cube. This is the field at a point on the axial line of a electric dipole. The direction of electric dipole is along the direction of the dipole moment. The direction is also very important because it's a vector quantity. Electric field is a vector quantity. The direction is also very important to note down. So the direction of E bar, that is electric field, is along the direction of dipole moment. This is all about the first and foremost application related to electric dipole, that is field at a point on the axial line of electric dipole. Then, so I hope this concept is clear to you. It's very easy. You can apply for axial line. First thing is axial line. We have considered the electric dipole at the axial line. In the same way, just a second. So first thing that you got it, I hope so. And the second thing is a field at a point on the equatorial line. Okay. The second concept application related to electric dipole is field at a point on the equatorial line of a dipole. How do you calculate then? Consider an electric dipole of a charge plus q and minus q. In the same way, let us consider the charge. Uh, this is the point charge minus q, and this is plus q. Okay, those are separated by a distance 2a. Right, this is 2a, and let P be a point on the equatorial line of the dipole. Equatorial means perpendicular to the line of a dipole. I'm sorry for the straight line. See this. Let us consider this is a point P equatorial. I mean perpendicular equatorial line of the dipole at a distance r. It is a at a distance r from the center of the dipole. Now, electric field at a point P1, electric field at a point P due to minus Q. This is the diagrammatic representation for field at a point on the equatorial line of a dipole. And this is at a distance see, if you consider the equatorial line, the angle made perpendicular to this axis, it will become theta, and this is also theta. That is perpendicular to the point P. Right. So even here even becomes, this is the actually net electric field. This is last important note to write down. But while deriving this, let us consider E1 is equal to same 1 by 4 pi epsilon naught into at a point charge minus q divided by what it will become at a point on the equatorial line of the dipole, because it is a perpendicular line. So it will become the square root of r square plus a square at a point charge minus q whole square. So this is equation number 1. Am I right? This is equation number 1. Similarly, for a electric field E2, the point charge at a plus q, it will become 1 by 4 pi epsilon naught into plus q divided by root of r square see, if you consider the point charge at a plus q, it will become not a square root. It's not a square root, it's just a uh, r square plus a square. I mean, by cancelling the square and square roots, you will get r square plus a square. And after calculations, you will get that electric field is equal to P bar divided by 4 pi epsilon naught into 1 divided by R plus A whole square 3 by 2 whole to the power of 3 by 2, because here the cos theta, okay, here cos theta, I mean perpendicular at point P, is equal to A divided by root of R square plus A square. Therefore, E will become P divided by 4 pi epsilon naught into 1 divided by R square plus A square whole to the power of 3 by 2. This is very important concept related to the field at a point on the equatorial line of a dipole. And at a point on the equatorial line of a short dipole. For a short dipole, by neglecting A, we will get E bar is equal to 1 by 4 pi epsilon naught into minus P bar divided by R cube, because it is opposite to the direction of electric field. That's why it will become minus P bar divided by R cube. Then the direction of electric field is, I told you that, anti-parallel to the direction of electric dipole moment. See, I told you that the direction of electric field is anti-parallel. Because of this negative charge, it is anti-parallel to the direction of electric dipole moment. So I hope this concept is clear to you. This is all about. So by the net charge, how will you net electric field? How will you get it? By considering electric field E bar is equal to E2 bar minus E1 bar. By substituting the values of E2 bar and E1 bar, you will get that P bar electric field at a net charge, that is E bar is equal to P bar divided by net electric dipole moment, that is P bar divided by 4 pi epsilon naught into 1 divided by R square plus whole square whole to the power of 3 by 2. So the direction of electric field is anti-parallel to the direction of electric dipole moment when it will be by considering the short dipole, that is E bar is equal to 1 divided by 4 pi epsilon naught into minus P bar divided by R cube. This is all about the field at a point on the equatorial line of a dipole. So I hope this concept is clear. Next, the last concept for today's session, that is uh, third application, that is field at any point due to the dipole. Field at any point due to the dipole. See, so by considering this an example, just a second. So the next third application related to the electric dipole, that is field at any point due to a dipole. That is field at any point due to a dipole. Suppose, okay, these are the two charges minus q and plus q separated by a distance 2a. Okay, separated by a distance 2a. Now let us consider the electric dipole moment P bar at anywhere else in the any area. Okay, in any area, let us consider P bar at any point, whether it may be very far away or very near to the those two charges. So let us consider P here at any point. The distance between at that point P to the origin O is equal to R. Then E net charge is equal to, here electric field E1 is equal to, I will write here E1, for electric field E1 is equal to 1 by 4 pi epsilon naught into 2p cos theta, because the point is perpendicular to the point O. Am I right? This is r cube. This is equation number 1. If you consider a point P here, E1 at a horizontal surface and E2 perpendicular to that point at a horizontal and vertical to that point. So E2 will become, this is E1 and this is E2. Now E2 will become 1 divided by 4 pi epsilon naught into that is at a horizontal surface P bar into sine theta divided by r cube. This is equation number 2. Then E net charge, E net electric field is equal to, by considering those two concepts related here, it will become E net is equal to this thing. So by substituting E1 and E2 in the E net, see, let us consider 1 by 4 pi epsilon naught is common here. Am I right? 1 by 4 pi epsilon naught is common here. And what is common? P is common here. And R cube is also common here. Then the remaining concepts are by taking the roots, 2 will become 4 4 into cos square theta. Am I right? 4 into cos square theta plus sin square theta will be written as 1 minus cos square theta. Am I right? 1 minus cos square theta. So by substituting this 4 square theta minus 1 cos square theta is equal to 3 cos square theta. 3 cos square theta plus 1. This is the final answer for electric field at any point due to a dipole. So by considering this in the mind, so we can derive easily. Am I right? See, I just did like this. E1 is equal to 1 by 4 pi epsilon naught into 2 p bar cos theta, which is vertical to the direction of at a field point P. It will become equation number 1. And electric field at a point P horizontal to the dipole moment P bar is equal to 1 by 4 pi epsilon naught into P bar into sine theta divided by r cube. This is equation number 2. By substituting and or by making an simplification, we did like this. 1 by 4 pi epsilon naught is common, p bar divided by r cube is common, and what is, by making into roots here, 2 square root of 4 is 2, right? So 4, the square root of cos square theta is cos theta, am I right? So 4 cos square theta, this can be written as 4 cos square theta plus What is the sin square theta? 1 minus cos square theta. So in 4 cos square theta minus cos square theta will become 3 cos square theta. The remaining is plus 1. This is the electric field at any point due to a dipole. So dear students, I hope this concept is very clear today. And in today's session, we have discussed about electric field and principle of superposition of electric forces, electric dipole, what is electric dipole, the electric dipole moment, and the applications related to electric dipoles are field at a point on the axial line of electric dipole, field at a point on the equatorial line of a dipole, and field at any point due to a dipole. So I hope this is very essential and very useful to you people. Make a work or make a note on this all and do hard work and you will get a success. So by saying this, I am going to wind up the today's session. Thank you. Please don't forget to subscribe our channel and please do share and subscribe. Thank you one and all.